Okay, let's clear up the scalar and vector products of unit vectors. This is something that is very essential to clear up before you start mathematical physics. The definition of a unit vector is in its name. A unit vector is just a vector with magnitude 1. So that means it just has a direction. It's pointing to one direction. It's showing us where to go. Like when we make a graph, the x-axis and the y-axis, they are pointing in some direction. So if we have to point at the positive x direction, I can call it I cap. That's a unit vector. Or if I have to go into the positive y direction, I can just call it j cap. That's a unit vector. And we can have scalar and vector products of these unit vectors and make an intuitive sense of what the output would be. So coming to the scalar product. A scalar product basically means that the answer would just be a magnitude with absolutely no direction. So the answer would be a number. Now whenever we take a scalar product of any two vectors, we just multiply their magnitudes and multiply them with cos theta. Theta here is the angle between these two vectors. All the unit vectors have the magnitude 1, so that part's pretty easy. And we also know the angle between the unit vectors we take. Like here, we are calculating the scalar product of I cap and I cap. So the angle between two I caps is just 0. So cos theta would be cos 0 and cos 0 is just 1. And we get 1 times 1 times 1, that is just 1. So dot product of I cap and I cap, or the scalar product of them, is 1. But if I do it with I cap and j cap, so dot product of I cap and j cap would be 0, because in that case the angle between them would be 90 degrees and cos 90 is 0 and anything multiplied by 0 is 0. So whenever we have the same unit vectors, the answer is 1. Whenever we have the different unit vectors, the answer is 0. This was scalar product. Now moving on to the vector product. Vector product, or the cross product of the unit vectors, is also very easy to calculate. We just need to write it as a determinant and solve it. I unit vector only has magnitude 1 in the I direction and it has magnitude 0 in the j and k direction. So when we do the cross product, we just write it as a matrix and we calculate the output and we get 0. We can actually make intuitive sense of it. Whenever we are calculating the cross product, it's like we're calculating volume. I cap unit vector cross product with another I cap unit vector. They are overlaying on each other. They can never have any volume. So obviously the answer is 0. Now let's try calculating the cross product of two different unit vectors. This time I cap cross j cap. So we do what we did before. We write it as a determinant. Now with j cap, it has magnitude 1 in j cap direction and 0 everywhere else. When we calculate its determinant, we get k cap. When I try to make intuitive sense of it, I like to see this as a 2D plane, the x-axis and the y-axis, and how do I turn it into a volume? I just push it into the third direction, so that's k cap. So whenever I'm calculating the cross product of I cap cross j cap, I know that the answer is k cap. And this is where it gets tricky. When we are calculating j cap cross I cap, what we get is negative k cap. Because we are calculating a determinant, we cannot reverse the order of I cap and j cap and still get the same answer. So this is something we need to remember. You can just think of it as going clockwise and anti-clockwise. The answer will always be k cap. But when you're in the right order, when it's I cross j, it will be positive k cap. But when you go reverse, when it's j cap cross k cap, it's going to be negative k cap. And similarly, we can do this for all other combinations.